Introducing the htx310 AI Accelerator. My name is Howard Nehal and I represent Applied Technology Research Center. The htx310 represents a paradigm shift in AI hardware design. Instead of chasing raw floating point operations, SkyMiser optimized for memory bandwidth and decode phase efficiency, the actual bottleneck in production LLM inference. This slide introduces the core specifications that enable the single card deployment of models that traditionally require multi-GPU clusters. This is a new card designed specially for AI, and it is recently been launched. Notice the emphasis on bandwidth efficiency over raw compute. Most accelerators waste power on prefill operations that GPUs already handle well. The htx310 specialization in decode phase inference delivers 3 to 5 times better token per watt for sustained conversational loads. The compression techniques preserve the model quality while dramatically reducing the memory footprint. We did an estimate based on what is available in the market. The pricing is not available, so we did our own estimates. These estimates are derived from TSMC 28 nanometer pricing data, LPDDR5 memory costs, and typical enterprise hardware markups. The wide range in this estimate reflects the uncertainty around software licensing and volume discounts. SkyMiser's messaging suggests they aim to undercut multi-GPU cluster total cost of ownership and not compete on raw price per TOPS with commodity GPUs. The tokens per dollar metric matters most for CapEx buyers with predictable workloads. Cloud users should evaluate cost per token or hourly rates instead. htx310's value proposition strengthens as the model sizes grow, where memory capacity and not the compute becomes the limiting factor. The maximum 240 power draw also reduces facility costs significantly. This ranking prioritizes the price to performance ratio for large language model inference, not training or general compute. Cloud options show higher tokens per dollar but require continuous usage to justify. For bursty or experimental workloads, cloud always remains flexible and is more suitable for such tasks. For production inference at scale, on-premises CapEx often wins if you calculate on a 24-month total cost of ownership. Always model for your specific utilization before purchasing anything. Never compare accelerators without defining the workload. A card that is optimized for 700B model decode will underperform on batch 7B requests, and vice versa. Also consider operational factors like team expertise, existing infrastructure, and compliance requirements, which sometimes often outweigh raw benchmarks. The best choice is always dependent on the context and the usage. This decision framework helps stakeholders avoid the common mistakes of buying hardware based on peak specs rather than the actual workload profiles. We recommend running a proof of concept with your target model and latency service level agreements before committing to any platform. SkyMiser offers early access programs for qualified enterprise evaluations. When contacting SkyMiser, be ready to share your target model architecture, expected QPS, and data sovereignty requirements. Their engineering team can provide customized performance projections. For internal stakeholders, prepare a simple total cost of ownership model comparing 24-month CapEx, hardware plus power plus cooling, versus equivalent cloud inference costs. We also have other brands related to IT and other subjects. Thank you for taking the time to see this presentation. Please provide feedback so we can improve our courses. My contact details are as follows in case you want to have any questions that you want to ask or give ideas on which other topics are of interest on which we should create more presentations.